Good morning, students. I'm back again with the second session on sorting. Today, we'll go a little bit faster on our topic. Today, our topic is bubble sort. Okay? Bubble sort. So, I will try to cover bubble sort along with another important aspect of sorting, that is, let's say, for example, I'm again taking the layout as a vertical layout and I'm showing you the values that I'm taking for sorting. So these are the elements which are there. Let's say 14, 12, 11, 13, 15, all are jumbled up here. So why do we need sorting? We need sorting only when the elements are not in any particular order. They are all scrambled. So that is the reason why we need sorting. But let's say you already have an array, which has got the values which are already in a particular order. Say 11, 12, 13, 14 and 15. Then why do you need to sort? We don't need to sort. There is a difference between this fellow and this fellow. I'm drawing a line in between. This one definitely needs a sort, but this one does not need a sort. But this one at least requires that you check once whether everything is in order. If everything is in order, then you don't need to sort. But let's say here I just change one element here. Let's say I make this 13 and 12. 13 and 12. That means now this is also not in order. But you see, according to bubble sort, bubble stands for what? Bubble means air bubble. Bubble means air bubble in water. So if you have seen the aquarium, okay, and you see that there is fish in water, okay, and you will find that there is a pump at the bottom of the aquarium, and this is your aquarium, and this is the level of water. You'll find that this is connected to a pipe, there's a motor here, and this is releasing what? Air bubbles. And these smaller air bubbles get distributed evenly throughout the water. Fish uses these air bubbles to breathe, but the rest, they all go from bottom to top and burst open once they reach the surface of the water. So that same concept we will use here to understand what's the concept of bubble sort. So here I hope you understood the example. I'm going a little bit fast today. So now you see bubble sort starts, as I told you, it starts from bottom. Same concept like yesterday. First thing that you have to remember is the number of passes that are required. Number of passes that are required. And number two, comparison per pass. How many comparisons you require in every pass. So if we talk about number of pass, same as the selection sort, number of passes is n number of elements minus 1. Total number of elements. So if you have 5 here, you need 4 pass. You have 10 here, you need 9 pass. And comparison is last element with previous element. See, the technique here is slightly different from selection sort. We are comparing the last one with the second last. We are going from bottom to top. And just like how air bubbles in water dance their way to the surface when they reach the top and burst open, same way we'll try to explain to you how bubble sort works. So we'll compare 15 first with 14. Is 15 smaller than 14? Is 15 smaller than 14? The comparison is less than. Why is it less than? Because we want to arrange the elements of the array in ascending order. We want to arrange them in ascending order. So ascending means what? Smaller numbers on top and bigger numbers at the bottom. So this is how it should appear. So is 15 smaller than 14? No, absolutely not. The second comparison is 14 with 12. Is 14 smaller than 12? No. Is 12 smaller than 13? we get a comparison. So yesterday one of my students sent a message on WhatsApp that she's finding some difficulty in understanding what is this interchange all about. So I hope I'll not take the name, but it is in general that I'll try to explain why do we need to interchange. We're comparing here is 12 smaller than 13. It is true. This condition that we're checking is 12 less than 13 is true. If it is true, we need to transfer. So I have two variables. You take for example, I have two variables A and B. One is having 13, one is having 12, and I want to interchange. I want to send 12 here and I want to send 13 here. I just can't say that B is equal to A and A is equal to B. This is wrong. Why? Because moment I say B equals to A, A's value will override the existing value of B. So if A's value overrides, what will happen? 13 will come here. But what happened to the 12? It got overwritten. So that is why what we need is a temporary variable. So the temporary variable will help us during the exchange. So we have A, B, and we have a temporary variable T. This is very, very important. So we have 13, 12, we want to interchange them. So either of them we can just first copy to here. So if we give T is equal to A, then 13 will come here. Now if we say A equals to B, if I say A equals to B, then let 12 come and overwrite A, no problem. I still have a copy of 13 here. So later on I can say what? B is equal to T. So the first expression was what? T is equals to A, so 13 came here. Then I said A equals to B, so 12 came here. Then I said B equal to T, so 13 went here. So this is how the exchange we are doing, and this is how this operation is also called, popularly called as SWAP, swap. This is called a swap. So students at a level in class 10 need to understand that what exactly is happening in the swap. So I'm again going a little bit fast now. I hope you understood. I hope the student understood what I meant here. And now I'm going ahead with my sort. So I have 12. Is it less than 13? Yes, it is. So I will take the help of T. I will transfer this 12 over here. I'll overwrite 13 over here. And then I'll copy 12 over here. Then as soon as I finish the comparison, I go up 12 with 11. Is 12 smaller than 11? No. But as a result of this comparison, you see, the entire comparison was based this way. It went bottom to top, just like an air bubble goes from bottom to top in water. So the smallest element, wherever it was, it went on top. And as a result of this pass, what do we have? The array now looks like this: 11, 12, 13, 14, 15. What is to be noted here is, I said that number of passes that is required is what? N minus 1. Total number of elements is 5. So 5 minus 1, 4 pass. But I already got it sorted here by running this entire comparison only once. I got this sorted or rearranged in ascending order by just performing the number of comparisons once. So then why unnecessarily run the remaining number of passes? So bubble sort technique tells us that you don't need to run. The sorting technique is so nice that if you have been able to successfully rearrange it in one pass, then we will just check one more time whether everything is in order, and we will declare that this array is sorted according to bubble sort. So the technique in bubble sort is that we go in books, some books you'll find that the comparison goes from top to bottom. No problem. Whether it goes from top to bottom or bottom to top, it means the same. The number of comparisons or the technique for comparison is the same. So I don't mind if students sort bottom to top or top to bottom. Whichever way they feel it is comfortable, they can go ahead. Now, coming to the code. So I hope you understood that if you have the array elements which are arranged In this way, the comparison always starts from bottom to top. This way, it will continue. Whether it has been able to exchange, interchange or not interchange, the comparison will keep on going from bottom to top. Unlike in a selection sort technique where you had performed, you took the first element, and you compared with every other. You compared in this way. So see the difference. Here you picked one, you took this fellow and you compared with A, B, C, D. You compared with each of them. So X, if it was bigger than A, then it got interchanged, and then again you took this fellow, same fellow, and you compared with the others. In bubble sort, this is bubble sort, it is not like this. In bubble sort, you go from bottom to top or top to bottom, whichever. I am comfortable going from bottom to top. So I have that, I am following the technique of air bubble in water. So as it goes from bottom to top, it pushes the smaller number on top. It pushes the smaller number on top. So if you have a situation like 15, 12, 11, 13, 12, see how 11, although it is at the bottom or in the middle, will go up. Or I can push it further down, I'll push it here. I have 11 here. See how it will go. First comparison is whether 11 is smaller than 13. Yes, it is. So this is T. I'll push 11 here. I'll overwrite 13 here and I'll push 11 here. The next comparison is not the last with the third last. No, it is the second last element with its previous. And it's still the same. See, 0, 1, the subscripts are still the same. So the next comparison is array subscript 3 with array subscript 2. Whether this is smaller, third subscript is smaller than second subscript. Yes, 11 is smaller than 12. So again we'll take the help. 11 is already there, or we can just overwrite it again. 12 will come and overwrite 11, and then again 11 will go and overwrite 12. So again it has climbed up. See how 11 was here, it is reached now here. The next comparison is the second subscript with the first subscript. So 11 with 12. The value is 11 with 12. So 11 goes here, 12 comes and overwrites. 12 comes and overwrites here. 11 goes from here to here. Next comparison is 11 with 15. Is 11 smaller than 15? Yes, it is. So 15 will come and overwrite 11, and 11 will go and overwrite 15. So anyway, you see, wherever it was, 11 kept on climbing. So the smallest value went up like an air bubble in water. So this is the whole concept of bubble sort. So you can turn it upside down, doesn't matter, it's the same thing. Now let us look at the code. For the code, I am going to take care of primarily two things. Number one, sort. That means I'll use the technique. The sort technique is going to be, sort technique is bubble sort. But number two, what I'm going to very importantly take care. Number two, what I'm going to take care is try to reduce number of passes. Reduce number of passes. So in order to reduce the number of passes, that means, as I told you, if the array is already sorted, then no requirement of again running the sorting pass again and again. Or if it is just required once, then we will run the sorting technique once and then just check whether they are in order and declare that the array is sorted. So I am taking it, I am writing from the top. Please, you can pause anytime. Char, I have taken a character variable sorted is equal to no. I am taking integer. T is a temporary variable, as I told you. So temporary variable followed by, I need someone to run the inner loop. So I have taken I. I'll take one more fellow. This is count. What is count going to do? It is going to count the number of passes that I am utilizing in order to arrange or rearrange this. So I am taking for granted that input of values into the array, declaration of the array has already been done. So array declaration and input of values in array is done. I'm taking for granted you have done it. So only the technique for sorting. So what we are doing, so I'm just writing here a star, that means you know there are two steps here, 1, 2. Now next is while sorted is equal to n, I enter the loop, and as soon as I enter the loop, see what is the value of sorted? N. So I use the value of n to come inside the loop, but as soon as I come inside the loop, what have I done? I have changed sorted is equal to y, so that in case the value of sorted remains y inside this loop, then it will not re-enter the while loop again. Inside, what am I doing? I am writing for I is equal to 4, y4. If this is your array, 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4. So you have 15, 12, 11, 14, 13. So the subscripts are 0, 1, 2, 3, 4. So I have to start from the bottom. So I wrote 4. You want to start from top, you say I equal to 0. I will write here I greater than 0 because I want to only go up to here, so that my comparison is, the last comparison is between the second element and the first element. You can run up to here. If you are going from top to bottom, you can go from here to here, so that your last comparison is this with this. I hope you understood. You can pause and check again. In case you have further query, you can contact me. I4, I greater than 0, I minus minus. Next, what is the comparison? If ARR within bracket i's value is how much? 4 means the last element. Is it smaller than ARR of I minus 1? What is I minus 1? If I is 4, then I minus 1 is 3. That means in the array, whichever is your subscript, 0, 1, 2, 3, 4, sorry. So ARR of I means ARR of 4 means this element. Is it smaller than ARR of I minus 1? I minus 1 means 3. So overall ARR of 3 is which element? This element. So I'm comparing whether the last element is smaller than the second last element. If it is, that means my array is not sorted. If this is true, mind what I am telling again, listen carefully. If this condition is true, that means my array is not sorted. So if it is not sorted, I have to rearrange. If I have to rearrange, I told you I took t here. So I will say t is equal to ARR of I. Next statement, ARR of I equal to ARR of I minus 1. And last statement, ARR of I minus 1 equal to t. So I did the interchange, but I knew that the array was not sorted. So what do I say? Sorted is equal to no. I push this further down. Why did I say sorted no? Sorted yes, here n. You please do a dry run. I hope you remember in my previous classes I have mentioned what does dry run mean. You label each of the statements in the loop, and then you execute it manually. You will know what the values of sorted are. Why did we take the value of sorted as n initially? We are considering that the array is not sorted. But as soon as we come inside, we said sorted is equal to y. That means we are taking for granted that the array has all the values which are in order. So it means I don't need to sort it. So if I don't need to sort it, this loop will fail next time. So if the loop fails, then the array is sorted. But if it is not sorted, for example, if the values are like 5 and 4, so this statement is true, the condition here, when I am checking the last with the second last. So what will happen? I will do the interchange, but I have to declare that the array is not sorted. Then, as soon as I come out, so this, what is this loop doing? what is this loop doing? What is this loop doing? This is the loop for running one set of comparisons. This loop is doing one set of comparisons. So if this outer loop runs repeatedly, then this is what this inner loop is doing the sorting. This inner loop is doing the comparison. So if this outer loop runs once, that means the number of comparison that I am conducting on the array is for one pass. So let's say the array is already sorted. The values in the arrays are 1, 2, 3, 4, 5. Then what happens as I run this set of 4 comparisons here, none of the times this statement will be true. Mark my words, if they are already in an order, if the array is already in order, so I'll compare, क्या 5 4 से छोटा है? No. क्या 4 3 से छोटा है? No. Is 3 smaller than 2? No. Is 2 smaller than 1? No. So every time I'm checking inside this for loop, this if statement, it is saying no, 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 no. So I'm not entering this body of the if. So if I don't enter the body of the if, what happens to this value of sorted? It remains y. If it remains y, so when it comes out, when it finishes the, when it comes out of the for loop, I've counted how many times I ran the number of passes. It will not re-enter the while loop because sorted value remains y. It will not re-enter the while loop. So my count value will tell me how many times I ran the number of pass, and my array is sorted. Thank you.